Hello GCC, this is the second video for Chapter 7 on polymers. We're going to look at some other plastics now that are not recyclable, so they're not 1 through 6. These are number 7 plastics. Nylon is one, a polyamide. Nylon is an alternative to silk. You can make toothbrushes, stockings, fishing line, rope, parachutes, and carpet out of it. The monomers are adipic acid and hexamethylene diamine, and that's a picture right there. I want to point out something. The squiggledy line, every point is a carbon atom. Every little where two lines point is a carbon atom. It's a shortcut. We're going to learn more about the shortcut in Chapter 8. But every little line is a carbon atom, carbon atom, carbon atom, carbon atom. We also have a couple of nitrogen atoms and oxygen atoms in this complex polymer. So nylon is also a polymer. Lycra, spandex, is a polymer. It's a polyurethane polyurea copolymer that was invented in 1959. It's used in athletic and exercise clothing, swimsuits, wetsuits, socks, underwear, unitards. We see Michael Phelps here showing off one of Speedo's creations that has spandex or lycra in it. It's usually mixed with other fibers, often cotton and polyester. So spandex and lycra are also polymers. Polyester is a very popular polymer. It's used in clothing, sheets, blankets, pillows. It's nice because it makes a stretchable fabric and it doesn't wrinkle, so it's very popular. Some of the names it goes under is Dacron, Polartec, and Polarguard. It's wrinkle and wind resistant, often blended with cotton. The more cotton you add, the more wrinkled it can get, and the less stretchy it is. So there's a picture of the complex polymer there. That unit repeats, and we see in there's a hexagon. See that hexagon with the circle in it? Every point of the hexagon is a carbon atom. Again, it's a shortcut on how to show organic compounds. So there's really 6 carbon atoms in that hexagon. Kevlar is also a polymer. This is perhaps the strongest one I can think of. It's very high strength material. We make really strong ropes and cables out of it, racing canoes, bicycle tires, body armor like you see here, helmets and bulletproof vests. So that's a bulletproof vest there. They're also heat resistant. They have a very high tensile strength to weight ratio, meaning they're really strong per gram. So Kevlar is another polymer. Why is it so strong? Well, most of the polymers we've looked at so far are just linear. They make long chains in one direction, just going across. Kevlar has a 3-dimensional network thanks to some hydrogen bonding. So if you look at the bottom here, you can see our 2 monomers. They both have that hexagon in them. Again, the points of the hexagon are carbon atoms. When you take those 2 monomers and put them together, you lose an HCl. So HCl comes off, and then we have that repeating unit. And as you can see in this picture up here, it makes a 3-dimensional array, and that's why Kevlar is so strong. Another one is Teflon. Polytetrafluoroethylene, PTFE, has fluorine atoms in it. It's a non-stick coating in pans. It was accidentally invented in 1938 while trying to make a new CFC. You should remember CFCs, chlorofluorocarbons. They were used in air conditioners. We made them illegal because they were killing the ozone layer, and we had that hole in the ozone because of the chlorofluorocarbons, the CFCs. But back in 1938, they didn't know CFCs were going to kill the ozone layer and make a hole and cause people to have skin cancer, and that they would be outlawed. So they were trying to make a new one, but they came up with Teflon instead. So Teflon is hydrophobic. That means water's going to bead up on the surface. So that's why if you put water in Teflon, it beads up. It deteriorates above 500 degrees Fahrenheit. When it does deteriorate, it's lethal to birds. It causes flu-like symptoms in humans. So when your Teflon pans are all scratched up, we don't want to give them to Goodwill. It's going to make people sick. It's just time to get rid of them. Throw them in the trash. And finally, we see the polymer unit that repeats there, the CF2, 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 and it keeps going. That is the polymer for Teflon. This just shows all 6 plus 7 together. Again, you need to remember 1 is PET or PETE, same thing. Drinking bottles, right? Soft drink bottles, water bottles. Number 2 is HDPE, the high density polyethylene. That's our milk jugs and laundry bottles. Number 3 is polyvinyl chloride, PVC, pipes. Number 4 is low density polyethylene, LDPE. Remember that? That's our shopping bags. PP number 5, the strong one, polypropylene. We make chairs out of it. 6PS polystyrene, styrofoam, which is not recyclable. And then number 7 is some of those other plastics we were just talking about. This chart's just fun. It shows 1 through 7 again with some of the original uses and then what we can do after we've recycled them. So I'm going to let you just look at that for a minute. You can hit pause if you want to. And that's where we're going to end this video. We'll check you out later, GCC. Thank you. Bye-bye.